Hello, everybody. Welcome to JaxDug April edition. Don't really have a whole lot of announcements this month, but if you want to comment there to the right down below the stream. If you have questions for Andrew, if you have questions, just throw them in the comments. As soon as he has a chance, he'll get to them. If you have any issues with the streaming as well, go ahead and throw it in the chat as well, and we'll try to help you with that. That's about all I have. Andrew, go ahead and take it away.
All right. Awesome. Thank you so much. Yep, I really appreciate the invite. All right. Hopefully you guys are seeing my screen here. All right. And present. There we go. So, yep. So for those who, I know many people in Jacksonville, but for those who haven't met me, I'm Andrew Carver, go by Drew. So I really appreciate the opportunity to speak today. So I'm a lead software developer over at Beeline. And today I wanted to give a talk on Fsharp and kind of combine a lot of different concepts. So today we'll be going over Giraffe, which is a micro web framework. We'll see how that fits into Azure and then explore some Fsharp along the way. So, and as he was just mentioning, I usually like to keep my talks interactive. So if there's questions or anything like that, especially when we get into the code portions, there'll be a little bit of slides here. And then as I get into the code, please feel free to ask questions. To me, it's a huge thing that people understand Fsharp. So that's kind of the intent of this talk, is to provide a very accessible, easy way to see how you can get up and running with Fsharp. And get started with Azure. So kind of demystify that a bit. So feel free to provide that feedback. All right. So yep. And as I mentioned, so today we'll be looking at Giraffe specifically. So I'm going to go over that framework, show what it is, what it does, and go over some of the concepts there. Kind of going to go over a little bit of a demo overview. So kind of created a business problem that's kind of practical, a little bit fun to go over. And we'll go over that a bit, what we're going to solve today, and then we'll get into the code and a demo. So we'll actually see it working. I'm going to take you all the way through deploying a function up in Azure, and we'll see it work in the cloud. So it should be fun. So, all right. Yep. So what is Giraffe? So Giraffe, as I've mentioned previously, it's just a functional microweb framework for building with rich web applications. That's the slogan on their site. So if you've used Web API traditionally in C#, this may look a little different to you. So the functional part is kind of the key word there. So I'm a big fan of functional programming. Scott Walash and John Vandergoes. I think functional principles have a lot of practical applications to web development. And so in this demo, I kind of wanted to explore that a bit and make this accessible. So I love Fsharp talks, and I've been to many of them. My whole intent with this talk here was to provide a bit more of a pragmatic take on it, because I feel a lot of talks get very lost in the weeds of all the coolness that Fsharp can offer or a functional language can offer. And to people that may come from OO backgrounds or may just be getting started in programming, it can look very intimidating. See all sorts of wacky operators, all sorts of weird names and weird terms that they've never heard before. And it can just be very inaccessible, I think, and intimidating for people to get their foot in the door, so to speak. So with this talk, I wanted to kind of provide a very fun demo that can show a practical use case for functional programming. It's something that you could easily throw into an Azure function at home or app service plan, Docker container, whatever, and play with. So and so please feel free to provide feedback during this with the comment feature. Just to guide me on how I can explain things better to achieve that. So, all right. So, where does Giraffe excel? Well, I've definitely mentioned functional many times thus far. So, functional, in my opinion, is a strength. And with that comes declarative routing. So, what do I mean by declarative routing? So, declarative is a way of coding is the opposite of imperative. So instead of we're saying how to do something, we're simply saying what needs to happen. So if you think of a declarative language, a good one that people may not have known is declarative, but are used to, SQL. In SQL, I'm not telling it how to pull things out of tables. I'm just saying show me the student records where the GPA is greater than 5 or 4. 4. Maybe if you're a really good student, but yeah, so that's kind of the idea. So we're just declaring what we want to see, and then the magic underneath of the functional language makes it happen. It's kind of a way of thinking about it. So it's just a different way of thinking about a problem, and we'll see how Giraffe exposes that in Fsharp. Another thing that I think, this is just kind of a personal opinion about Giraffe here, has really good model validation, blending with Fsharp. So Fsharp, it's no surprise to anybody, is not as popular as C#. C# is kind of Microsoft's flagship language, and for good reason. But I've noticed that a lot of frameworks kind of have a object-oriented take on Fsharp. And one thing that I really liked about Giraffe, and why I picked it specifically for this talk, is I feel that it is really true to those functional principles underneath. So you can kind of see functional programming in action. So some of the features that Giraffe offers as well, nested routing. So we'll see how it handles that. It has this is my language, Fsharp friendly route parameter parsing. What I mean by that is if you've ever used the sprintf function in Fsharp, it has very nice little syntax, and don't worry, we'll see this as I get into the code in a second. But it has a very friendly way of pulling route parameters out that I think is pretty cool. So I think that's a cool feature. Is native task support. So this may be something, if you're not used to Fsharp, you kind of raise your eyebrows and be like, well, what task support? So Fsharp has its own take on asynchronous programming by the async type. So they've come up with their own type. That sometimes gets a little tricky when you're integrating with C# code or libraries that use the task of T type that you may be used to in a C# world. So this just kind of bridges the gap there, is all that's going on there. So it's just making it friendlier to work with that. But we'll see how it's really not something you have to keep in mind. It just works. And then the built-in model validation, I think, is a really cool feature. All right. So some of the benefits that I think Giraffe really highlights in web programming. So I think it really dovetails nicely with a railway-oriented programming model. If you've never heard that term, there's a really good blog here, Fsharp for Fun and Profit. I highly encourage anybody that's not read Scott Wolaschen's work to give it a click or a visit or Google search. It's an awesome site, and he has very pragmatic, deep in the weeds of category theory ways of explaining pragmatic business application explanations for functional programming and Fsharp. He's a big Fsharp advocate. I've fallen in love with his way of explaining problems. It's helped me being I'll admit I'm not a math guy in school. So anytime anybody breaks out the category theory and the lambda calculus, usually I start to wonder, okay, well, I usually solve business problems. So I think he does a very good job at explaining in an accessible way how functional principles can make your business problems solve them in a much better way. And I'll just briefly go over to the site here just to kind of give you a demo of what his blog looks like. Highly encourage it though. So railway-oriented programming, he has a really nice diagram here that he kind of explains. So we can see this is the happy path. So what we would describe in programming is the happy path, the one that we hope our code stays on most of the time. But we always know that things happen, null references happen, things like that happen, and so you may end up on the sad path, and that's that rail going off to the bottom here. So if we think abstractly about even with web design, right, and with specifically with APIs, right. We can easily kind of think of that. We have two tracks, right? We have the success, my 200, I get a payload back. Things are good, life is good. And then we've got the sad path of, 500, 503, 401, those paths. And that would be the sad path here. And even in the code at different layers, like you can see here. So he has a validation error. He has a update DB error. These all kind of go onto that other side rail something's gone wrong and we need to kind of eject, and hit the abort button on this request, and let the user know that whatever he was trying to get accomplished didn't happen and can't happen. So that's kind of what this model achieves. And we could see in Giraffe as a framework, it's very friendly to the style of programming. So I think this is a very powerful way of programming. There's obviously a lot more to this that Scott Wolaschin explores here and that we could explore today, but just kind of keeping it surface level for now. Yep. All right, moving on along. And here's another diagram more specific to Giraffe itself. So this is kind of the railway-oriented model without the SAD path represented, but you can see the composition. So thinking back to that diagram that I just showed from Scott Wolaschin's website, we have a compositional nature that's happening to all of those tracks. So you could see how they all kind of merge together into one. And Giraffe is modeling that as well here. So it has a concept that it calls HTTP handlers. And you can see these little handlers. So they're almost like kind of like middlewares you can think about, where they just kind of glue on to the next guy. And they handle different specific things. So we could have one that's routing to, okay, I'm only going to respond to GET requests. So that's filtering down the request here a bit. And then we're going to determine whether the route matches my particular route, a specific route. And then we're going to compose onto another handler and then add the response body. So maybe they were asking for, students, and I'm writing an API for a school. So it composes all of these together. And all these little functions are basically little tiny pieces of single responsibility in the chain of completing this request here. And then we return back to the user the result. So hopefully that's making some sense. But that's kind of the idea behind Giraffe's way of modeling this. Yep, and here's some text explaining it a little bit further. But yep, so it takes an HTTP context object, and then it handles it, and then we end up with a response, and it's just one big chain of them that goes through. All right, moving on along. So project overview. So I don't know about you guys, but during COVID, I've had a lot of indoor time. So a lot of time at home, just sitting around. So my wife is very into this game called Animal Crossing. And my wife generously purchased me a copy as well. So we've gotten to enjoy this together. So it's been a learning experience for me. So I have never played the series, but my wife loves the series. So so we played this together. So I was introduced to this game and the mechanics of it. So as you can see, my wife has had influence on the slide as well. So we got the cute little figurine here at the bottom. But it got me kind of thinking about this. So when I sat down to do this talk, I just thought it'd be a fun thing. I don't know if anybody else has played this game or not, but there was one little part of the game that made me think about this. So there's this part of the game where you purchase turnips. So you can see this character here. I don't know the name of the character, but my wife definitely would. But these little turnips up here at the top. So you go talk to this character every Sunday. And you purchase them. And they start on Sundays. The only time to purchase these turnips is on Sundays. And you invest a certain amount of money in purchasing these turnips. And as you can see here on the blurb, you must sell them within 6 days. So if you don't sell them by next Sunday, they go bad. So you lost your investment. So every day of the week, you have a price on your game for these turnips. And it could go up, it could go down. It's kind of random. Some people, think there's patterns to it. My wife got very competitive looking into all the plausible explanations for this algorithm. But the one interesting feature was that the more people that play this game, I'm guessing this was a part of my wife's decision making in providing me with a copy of the game, is that you can visit other players' games and sell turnips. So say I have a good rate going for the day for these turnips. My wife could visit my island and use it to purchase those turnips. So, that's kind of the idea. So in the in-game currency here is called bells. I don't know what the significance is. There's coins, but that's kind of the general idea for this business problem. Yep. So we'll get into this, but I've basically written an API that allows players to essentially save their rates for the week. The idea being that we could put some front end in front of this, and then players could go on and post, rather than what typically happened with us, where my wife would go on Facebook and reach out to all her friends and type. This would be like a website that you could go to, and you could post your rate for the day, and people could look at it, quickly see which place they want to visit, which friend they want to visit. So kind of the fictitious example and project I created for this demo here. So that's what we'll be exploring. So without further ado, I will get into the code. So pull up my VS Code here. So we will get started over here. So I'll say up front, so this is written as an Azure function. I did this purely for fun, but I suspect that this is probably not the ideal use case for Azure functions. You typically would probably break this out into its own app service plan if you were to host since Azure functions allow you to define HTTP triggers for unique routes. You probably want to break this up in Fsharp if you did. I did this purely as an exploratory exercise, but I'm just announcing that up front. So probably if you were doing this in a production environment, you would want to put this in an app service plan and scale it that way. But I wanted to play with Giraffe and just to kind of as an exploration side project. So this is in an Azure function app. But the benefit is that we'll get to see how easy Azure functions are to deploy. Yep, with that being said, we'll get into the code here. So for those that are curious about Azure functions themselves, so it can be a little tricky to set up something like this. This is how you would set it up in Fsharp. This looks a little funny, but I'll read the code here and kind of explain what's going on. So it's a bit of admittedly of a hack. So there's these do blocks within Fsharp here. We're doing unit, which is basically nothing, and then we're using this decorator here to achieve this binding up here where we add Giraffe in. So that's kind of the idea here. Yeah, and before I go any further, so for those who haven't used Fsharp before, because that's where I really wanted to gear this talk, you can see here I have the tooling installed, and you'll probably want to do the same if you use VS Code here. So the extension I tend to prefer personally when I work with Fsharp is Ionide, and I think that's pretty popular. So I have Ionide installed here, and you can see that I'm getting what looks like comments here. These actually aren't a part of the code. What it's doing is it's providing me what that type is on that line. And this is really helpful when you're programming function in a functional way, because everything is always about type signatures. So that's kind of the entire goal. That helps keep your code honest as you move through the code, because you're not necessarily relying on side effects anymore. You're reacting always against types and concrete results. That may be a great topic for another talk. And Skabalaschen is a great resource for that on pure functions, referential transparency. Those are kind of the terms that are thrown around in a functional sense, but Fsharp helps you a lot with that with this tool. So where it's providing me the result of each resulting type on each line of code, or in this case, a function. So, all right. So let's get into where the routing is happening. Here you can see I have my app. So remember how I was saying that it was declarative. The declarative part here, you can see, is this piece here. Now, this may look very different than what you're used to writing if you've written C# Web API controllers. So I'm not inheriting from anything, and this isn't object-oriented. I'm simply composing together HTTP handlers, as I was mentioning before. So we can see here, this is my API. And you'll notice that I have these, so I will admit I have a goofy font installed here with something called Ligatures. So these icons that are being rendered here are just kind of the enhancements just to make my code look a little prettier. But what these symbols are, I'll type out here. You can see it work. So this is a pipe operator. you see it change to a triangle, so it automatically kind of corrects it and makes it look a little different. This operator right here is commonly referred to as the fish operator because it looks a little bit like a fish. So we can see it here. Yeah, and then that's what it actually is right here. So you can see it's the greater than, equal, greater than, piping it along. So here, it basically serves to compose together HTTP handlers. And that's one interesting thing about Fsharp here is that you can actually define these operators as functions themselves. So if I hover over it, this is coming from Giraffe. So Giraffe has defined this operator here. And we can see here the type signature of it. So whenever in functional programming, it's very common to look at the types and drive your code through the types. And the way to read this, for those who haven't read code like this before, the way to read this is to read this as a function that takes in these arguments, and this is the return type. So at the very far side, if you ever see parens, in this case, it's just wrapping this. But if you saw, if for example, if we saw parens around this type here, that would mean it's returning a function at the end of it here. So it's a grouping. So that's kind of a little bit of a marker just to kind of help people get used to what this reads like. I know I've covered a lot, so feel free if there's any lines of code here or anything, as I was mentioning with the chat feature, please feel free to post it, and I'll do my best to answer it. So whole intent is just to kind of help people make Fsharp a little bit more accessible to people. So please feel free to do that. All right, so keep going here. So feel free to interrupt me at any time if you have comments come in. I'll do my best to answer them. So this here is filtering by a post. So we have a choose here. We can see this is just basically a grouping of routes here. So it's just an array of handlers here. It'll match the first one that it hits. So that's kind of how this works. So we see here down at the bottom, not found. Could match out there. So that's how Giraffe works. I will say for those who haven't coded in Fsharp before too, it is, it's probably obvious at this point, it's a white space delimited language. So there aren't many curly braces, aren't many semicolons. So it's very different. So you will get compile errors if you code in it for improperly indented code. I will say, as a personal opinion, coding in Fsharp, I found the tooling around Fsharp to be very welcoming for new developers that aren't used to that. It's the proper indentation. I believe the error itself will actually tell you if you have improper indentation or it suspects that. So it's a lot friendlier, I think, than some languages where you just get red squiggles everywhere and you wonder where you went wrong. So very, very helpful there. So moving on along here. So we'll take this route, for example. So this is just to add what I refer to as an exchange. So going back to our business problem here with the exchanges, the Animal Crossing exchanges. So I came up with the name exchange. It represents a particular week in which players are playing. So we have exchanges and then we have markets. And the market contains a individual player's score for the week. So their purchase price and then the prices for each day for the turnips that they're offered. So that's where the markets are stored, and then the exchange is simply a week for all players to participate in. So that was kind of how I modeled this business problem here, and that's the nomenclature I went with for this. So a little bit of DDD fixed in here too. So this will be our aggregate right here. So moving on along. So this route here will just match API exchanges. You'll notice I have this little warbler function here. And actually, I believe this will be even more helpful if I tab over here and we move over to Giraffe's documentation. So this is where Giraffe documentation lives, Giraffe Wiki. They actually do, I think, a very good job at documenting their code here. So feel free, if you play around with this, to give it a look. I found it to be kind of helpful. This is explaining here the compose operator that we just saw. So the fish operator. I think he gives a shout out here. So we can see it used down here. This is just another use case showing the compositional nature of it. And that's very common in functional programming for those who haven't done functional programming before. So you can take functions and then just glue them together, just like we saw with the railway example, and arrive at a function that solves a much bigger problem. So it's like the composition of its parts, solving the problem. So there's no limit to how many you can glue together here. So this is the choose combinator function here. So you can see that it's using functional programming nomenclature, but for those who haven't coded in functional programming before, I think it's fairly intuitive to see what it's achieving there. So this is the warbler here. So why do I need this warbler here? This is kind of goofy. So what it's doing is it's essentially allowing me to execute this function every time. So as it explains here, these functions are eagerly evaluated normally, and that's not what we want. So we want, in this example, you can see here, like, if I was to return the time, probably would want a time endpoint to get the time every time rather than just the first time. So that's what it's doing here. So it's just it's referred to as a thunk, an FP. But we're essentially just wrapping it with another function to make sure that it's run every time through this warbler function here, HTTP handler. So moving on along. Let me just make sure my sound is working here too. We're good. Didn't want to miss any questions. Moving on along here. So and this is just an inline lambda function. So for those in JavaScript or in C#, this is just a lambda. That's how Fsharp writes them. So we just have fun. Underscore represents the absence of an argument here that we're going to ignore. It's just kind of a shorthand. So we're just saying, I don't care about the parameter that's passed in normally, and just wish to execute this function for the result. So moving on down here, so we could see some other routes. So obviously we're going to need to take in a resource-driven fashion an exchange ID, obviously, to return a particular exchange. So if I'm interested in a particular week for players, imagine the UI that I was referring to a second ago. So we build out this UI here, and an individual player changes to a particular week, and maybe the current week, to see, okay, what was, what's the market look, or the exchange look like today. That's what this route would support here. You'll notice that this looks kind of similar and different if you've used C#. So this %s here is actually a specific convention that Fsharp uses, and this routef function takes advantage of it. This will actually extract out and tokenize this particular part. So if you've used like React routing, I believe they use colon. This is actually a part of the language here. We just basically get all that cleanness for free. So this just takes out the exchange ID here out of this part of the route, and then passes it straight in here. So we get our exchange. And then these as well are very similar. This actually, if you might ask the next question, well, what happens if I have multiple, right? It just essentially gets merged into a tuple. Tuples are very common to work with in FP as well. Provides a very handy way of just providing multiple values here. So we just destructure. So this is destructuring right here in Fsharp. So we pull out the exchange ID, we pull out the username, and then we just pass it on along. So very, very clean, in my opinion. And there you go. There you have it. So that's our whole API here from a high-level routing perspective. So we can kind of ignore this piece here. I have that up in GitHub. This is just wiring up the function app into Giraffe. So a bunch of boilerplate code here. So we'll let that be for now. But let's jump into one of the handlers here just to see what that looks like. So we'll go with get exchanges here. Click on this. So actually, let's start up here. This will be a little less overwhelming. So you'll notice here, I have this create exchange builder function up here. You may ask yourself, what's going on here and why am I doing this? So the reason I'm doing this is because this is a functional strategy pattern. So you'll see here, I actually have this dependency or a signature matching this exact signature up here. So if we scroll to the right here, we'll notice that these types actually line up here. And that's on purpose. So in functional programming, functional strategy pattern, we simply just, as you probably guessed it, use functions to solve this problem here. So this makes it very easy to unit test as well, that we'll see in a second. So I have a full test harness built out for this. We'll see how easy it is to create unit tests. So we won't actually have to use a mock or stub library. We just use functions again, as you guessed it. So yep. But that's exactly what this is doing. And this is the part where we call our database. We are using this operator here. This is a pipe operator in Fsharp. So it's going to take the value of this expression over here and push it into this one. So here we are getting the exchange. We're getting the collection here. So this is the Mongo collection. So I'm using Mongo as our database. And then we are pushing that into this function here. So that's what that line of code is doing. Yep, moving on down. So this is the general function syntax. I broke this up on purpose. I could put all these arguments up here as we were looking at previously. So if I look at this function here, we'll just see Fsharp doesn't make any distinction between them. It just shows that this is a function that takes this argument, this one, and then it returns this at the very end. I could move them up. I did this for style because this is the part where Giraffe dictates this is what an HTTP handler looks like in Giraffe. So I broke this out on the next line just for readability, but just wanted to toss it out there in case anybody was curious. And all this code is on GitHub. I have it on the last slide. So if anybody wants to download it, play with it, critique it, whatnot, feel free to do so. So yep, moving on along here. So this is the task I was referring to for native integration with tasks. So this is known as a computation expression. It's Fsharp's way of handling asynchronous code. So we can see here, I have let bindings here, but I have this operator at the very end. This is basically the equivalent of an await. So if you use C# or JavaScript promises, you'll use an await to await a promise or await to await a task. Same idea. For this block of code here, anytime I use this exclamation point, I'm awaiting the result, so it changes. And we can actually see that here if I remove this here. So my code will blow up, but it'll also say task of T now. So if I undo it, now I get something I can work with. So that's what's going on there. So hopefully that clears it up a bit. So this particular function right here, this handler, is just creating an exchange. So this is kind of the starting point for the API, if you will. So this is where we'll create a week. The player will come in. You're going to create a week and get started posting their scores for the week of their prices. So you can see we have to get the week that the user is trying to create somehow out of this. And as I was mentioning earlier, this is the syntax they use for grabbing the model out of it. So just context as a native little function here, bind JSON async, and we just hand it a model here that we create in Fsharp, and it pulls it in for us, and we'll validate it. So you will notice here, and I'll explain this here as well, the CLI mutable attribute. So Fsharp is immutable by default. So the CLI mutable attribute here allows us to interface with things like this that they need to achieve mutability on the model. You'll notice it a lot on database models as well. So that's all that's going on there. So moving on along here. So here we create the exchange, grab the week start date for the user from the user, and then you can also use the exclamation point on the return statement, and we do here as well, because this is also a task right here, this expression. This is Fsharp's pattern matching syntax. If you've not used Fsharp before, it's very clean. So match result with, you may notice that C# just had that introduced and they use switch statements. Fsharp uses this match syntax. I tend to prefer this one, but teach their own. And then poor old JavaScript obviously doesn't have any, so we'll laugh at that. Yep. So that explains that handler there. Hopefully it's just making some sense. Yep. And then we return. So I'll speak to these results here. So Giraffe exposes these handlers as well. These are also HTTP handlers, created, conflict, all the popular ones, obviously that you would use for status codes. They're all nicely wrapped up into the micro framework. So I can simply just say created, handed a item here, and then these two function. It works just like a middleware. So this continues on the HTTP handler chain here. This ensures the continuation of it. Or we can represent an error. So hopefully this is starting to make some sense to people that may not have, if this is new to you. So Railway, you can see the Railway-oriented programming approach starting to surface here. So we can see I'm getting a result back. We can see is this result type, and then I match against it, and I may get a result of OK, or I may get one of error. So this is where the two paths. Yep, and you see Fsharp actually has very good, I think, documentation and kind of hand holding with this. So you can see what's going on here. So I think this makes your handlers here look very clean. It's easy to see what's going on here. Yep, it's just a simple Railway-oriented programming. So it makes it as easy as that slide looks. So we just have the two tracks there that are happening. So yep, that's that. So this is the create route here. So we're moving on along here. Create market route. So you'll notice too, another common thing with functional programming, type unions. So these are some types. So I believe Scott Woloshin refers to them as choice types, but essentially it's just a union. What this means is if you are used to inheritance, that would be a product type. So I'm taking types from the parent and then kind of adding them. So the child is everything that the parent has and also this other stuff. Union type is useful, or a choice type, to borrow his language, is a way of representing things that may not actually share properties, but share a logical idea. So in this case, I'm using a market create operation to get into DDE a little bit, maybe something a little more practical. I think a good explanation is a contact method. So the person could have an address, they could have a phone number, they could have an email address, right? None of those types actually line up in any way, sharing any common properties, but they have a logical idea in that maybe I have a business requirement at some point to, I have to have a user with at least one contact method in the system. So a union, a choice type would be a great way to model that, because I can just put them all together and then create a business rule and pattern match against it, like we see here, and say, well, you got to have one. So that hopefully that clears that up a bit. So we can see here this function here, very similar approach here that I've taken, and I'm matching against the result coming back from this function here, and I'm modeling all of the cases underneath that could happen. So we could have this go successful. I could say I couldn't find your week; it's not been created yet. Or we could have something terrible happen, and then give the wonderful descriptive and internal error occurred that we commonly show to people. So hopefully this is making sense. The indentation too here, I tend to like this approach here. I think it helps readability, but it's just a stylistic choice. So moving on along here through the handlers. So this particular one will get an individual exchange. So similar code here. And I don't think there's anything new here. And feel free to download this code too. Again, as I was saying, if you want to play with it, see how Fsharp works. I have found it a great experience playing with it as a language. I think it's very accessible. So feel free to tinker with it if you like. So moving on to get exchanges here. So we can see here, it's a very similar function here. Yep, so I have some bad request logic in here that we use. In case, so yep, so just dovetailing together here. All of the validations, speaking to this line of code here, so I'll just point out this operator here. This was honestly the scariest part of functional programming to me, was the operators, because I think C# is one thing that shines in is that it's very verbose in some ways as far as how code is written so it's easy for people to read. F# and other functional languages tend to rely a lot on operators. So speaking from experience with bad experience with math, because I'm not a math guy, I think it can be very difficult sometimes to see code like this and feel intimidated just because you don't know what it means. So this looks like wingdings to anybody that doesn't understand what it means. So if you're ever programming in F# and you're curious what it means, you can hover over it and then get this type information as I've been speaking to. Now, you may hover over it and then think this didn't help me at all. This looks like Greek and it feel even worse. So never fear. I'll explain what this means here. So the apostrophe here in F# just stands for a generic. So this could be any type. What this operator is doing here, what it's demonstrating, is this is a way to compose two functions together. So we're gluing them together. So if A goes to B and B goes to C, then I have a function that goes from A to C. So that's all that means. And it gets easier the more you work with it. From personal experience. So stick with it, it gets much easier. But we can see here, so it's very common in F# and in functional programming to code this way. So I can just easily in one line compose together a larger function in one big expression and then toss it into this bind function here. And I've solved my problem. So very, very cool stuff. So hopefully this is making some sense, but just trying to kind of highlight some of the things that may intimidate those that haven't worked with F# before. So moving on along here. So we have our update handler. So this is if somebody wants to add their scores. So I provided this route to update your prices. So we can see up here, and I'll speak to this in a second in the models here, but I represent this as nullable. So this is the way that we can get around serializing, since we can't use an immutable model for that. So we use the nullable of T here. F# has another way, and you'll notice that I'm transforming things. I'll speak to that in a second. It has a very elegant way of modeling options that you may actually, in C#9, they started to kind of move that way with the non-nullable reference types. Moving on along here. So, and this is very similar code to what we've seen in the others. I will focus on the models now. So this is actually a great transition point. And again, I'll say it again. Feel free to surface questions if you see something that you've not seen before. You have a question, I'll do my best to answer it. So please feel free to interrupt me at any point. Notice I have this bells here. I'm just doing a simple type alias. So this is a common thing. If you ever coded in TypeScript, it's a common convention. TypeScript too. It's a great way, since in functional programming we rely on types a lot. Integer doesn't tell me a lot of information, but if I alias it to something that does give me a little bit more information, it's easy to do so, and it makes my code more descriptive. So here I alias it. There's some other tricks you can do, even deeper than this. Units of measure and such in F#. I won't get into that here, but they're there. So, main idea here being, don't be afraid to leverage this feature if you start coding in F# to make your code more descriptive. Moving on along here. So here we have the exchange. So this is the main endpoint that most users using our API here will interact with. So and this is getting serialized to Mongo here. So that's the BSON object ID that we're seeing here. So I just have a simple transformation function. It transforms from our database model to something that can get returned to the client. So that's what's going on here. And this is the part I kind of wanted to get to. So you'll notice that I have up here at the top, I have this market, and I have Bell's option. So this is a F# feature that allows you to basically wrap a property that could or could not be absent. And I'm being specific with my language there because in C# traditionally in an object-oriented use null, but null kind of creates a problem. And the problem is that null isn't always specified with a particular function. So if you have a particular function that returns null, it'll just look like this in C#. So it's left to the consumer of that function or method in an object-oriented model to know that you can return null. So in functional programming, it's common to wrap types with other types. So here I have a, and I'm not, it won't hover the IntelliSense here, but if I hover over another property here, I may get it. But it's basically an option of T. So in the same way you have a nullable of T here, it's an option of T. It results to two concrete things. It could be a sum or it could be a none, but it's explicit. So if you see an endpoint in Fsharp that returns an option, it's imperative on you, and you actually cannot access the underlying value without handling both cases. To kind of go back to the railway-oriented approach that we were talking about a second ago, this enforces that, and that's a piece of that. So this makes our code much safer, because I could easily code something like this and then hand this to somebody else, and they would understand, oh, Drew sometimes has something to return to me and sometimes not. So just a handy tool in your tool belt when you're programming in Fsharp. And you may have noticed the result type that I hovered over earlier that handles the OK and error. That's very similar to option. The only key difference is that the error case can also hold something else. So I could put like an error message, for example, in it and return it. So just to capture some information about the error, but same idea. So hopefully that kind of demystifies that a bit. And we have these nice little friendly transformations here that I can leverage here. So moving on along here. So a couple more utilities here that I've written. So this just parses the date here. One nice feature about Fsharp is that out parameters get put into a tuple. So here I can pattern match. So normally, it's always kind of felt clunky to me in C#. I think they've cleaned it up a little bit, but I really like the fact that I can just pattern match here and just say, in the case I get true, and parse date, capture that in what we call the closure. And then put that into a sum here and transform it. So now I have a little handy utility function here that takes a string and returns me, as we were just saying a second ago, this is actually a perfect transition, an option of T, option of date time. So my code consuming this will have to handle both cases, whether it's there or not. So query string utility here, very similar thing. So, yep. All right. So I think that's the code kind of walked through here. So let's get into let me hide this here really quick. There we go. So we can go over here. If you've never worked with Azure functions here, so there's a little, actually, you know what? I believe, okay, let's start tests. I think it's already running. Yes. Okay, good. I'm glad I didn't try to start it twice. That would have given me a funny error, port in use. So let me stop this here really quick. Well, I can leave it running. This is func start. So if you run func start, I'll just type that out over here and leave this going. But func start, this starts an Azure function. So that's all it's required. So just download the Azure Core Tools. Or Azure Function Runtime, I believe it's called. You'll know it when you see it. Yep, just simple tool here allows us to start up a function and we can run it locally. So before we deploy to the cloud, we can see the function running. So we'll go over here. We'll give it a test. So let's go ahead and grab some exchanges here. So this is hitting a Mongo database, and we can see some test data that I've already added here, but we can see a status coming back. So this is hitting our local route here. So yeah, we can insert some things. So let's go ahead and pick another week here. So let's pick week of the 28th. All right. There we go. 2.1 created. So came through. Yep. So it's all up and running. So I won't bore everybody with going through every single endpoint, but this is kind of the general idea. We can see what this looks like being serialized back. So it's all up and running. So we're good to go there. So you may say, this is great. What about unit testing? So we got all the types and everything lining up, but what about unit tests? What does this look like? So unit tests here. So I'm using XUnit. And if we close this here, yep. So this is what a unit test looks like for this. So we can see here, I've got these functions that I've named mock here. So as I was mentioning previously, the functional strategy pattern, and actually I believe I have a nice little handy link here. I've included it at the end of the slides here. This has helped me a lot, which is kind of thinking differently and just a different way of approaching a problem. I guess it's a good way of putting it. So O has a particular way of handling this problem. This is a functional strategy pattern. Scott Woloshyn has a wonderful blog post here, and he has in several talks great descriptions and walkthroughs of how to approach this problem functionally, but this is the general idea. I've linked this at the end, so in case you're curious about reading up on it. But that's exactly what this is here. So if we go back to the code here, so we can see the type signature. So this looks very similar to the type signature that we had previously. If we come over here, we'll see that all it takes to test my code here. So that's usually whenever you're modeling a problem here, that's the tricky part, right? Is, how do I abstract away the database? Because I obviously don't want to integration test my app every time I run the test harness. So how do I put a dummy value in there, but then treat everything else the same here? And that's exactly how you do it in this case here. So we just run our handler, we get a result back. And then in this case, we're actually running it all the way through Giraffe. So we will actually get the actual payload that the user sees. So it does all the routing, everything except for the database part. And then we just do a simple should equal at the end, and reads almost like English. Use the pipe operator, and we are good to go. So pretty slick, I think. Very handy. Yep, and that's all there is to it. Yep, and we have all our unit tests here. So these are all testing. Yep, happy path, sad path, and it's easy to mock the sad path here because we can just simply, just invent a terrible error and then return it back. So we don't have to worry about how to stage that error. It's just part of the mock. So there we go. So moving on along here, and I'll pause again here for a little bit of coffee. But please, if anybody has any feedback or questions or anything like that, please feel free to jump in, throw a comment in as I go through the code here. So intent is just to make this as accessible as possible. So if you have any question or anything, please feel free to throw it in there. All right. So, all right, moving on down here. So, yep, these are very similar here. Yep, you can take this approach to pretty much every handler you write. So we have the same thing all the way through. Yep, and as you can see, I can just mock payloads here. I can mock return values. It's really a non-factor. I don't have to pull in any other library. It's simply just a function. So, yep, very, very easy to write. So, yep. So, and I'm just going through all the tests here just to show there's nothing up my sleeve. So, yep. We can even test query stream parameters here. So I have a route testing query stream parameters. So when you get exchanges, you can filter by week. So we can obviously access a particular week, but if we want to look for a week, so that was one use case I also solved here as part of the API. So maybe somebody's coming in there looking for a particular week that they want to, by the week value, by calendar picker. So that'd probably be the primary case that somebody would use. So that's supported. Yep. So overall, that's all there is to it. So let's go ahead and give it a run here. And until I've already given it a run before the demo, just to make sure. But we'll give it another one just for fun. There we go. Yep. So you can see all 13 of our tests pass. So we are good to go there. Yep. And that's all there is to it. So yep, fully unit tested from with the exception of the database. So very easy to write in a functional way. So this is, just a functional approach to unit testing here and mocking that dependency with a functional strategy pattern. So cool stuff. So, yep. All right. So now we get to move to the fun part of putting this into Azure. So I will go ahead and give a little bit of a brief overview about how this whole thing works here, in case anybody at home wants to try this. Or anybody wants to play around in the cloud. So here I have MongoDB Compass. It's a great tool that Mongo provides for free if you need to interact with the Mongo cluster. So you can see here, I've saved my credentials. You get a little bit different experience. You download it for the first time, but you may be asking what database I'm connecting to. That doesn't look like a local database, and that would be true. So I am using MongoDB Atlas. So you can actually, function apps, Azure, last I checked, you get 1 million, I think, executions or something crazy for free every month, I believe. And here you can see starting it free. So if you want to play in the cloud, if you want to have fun and play with some of these tools, don't feel intimidated that it's a price thing or anything like that. It's easy to pick up these tools. Just give it a shot. You have nothing to lose. So it's tons of fun. So it's a great learning experience. I've had a lot of fun working with this. So so feel free. And this is just a cloud database. So just create an account, spin it up, and you're good to go. This is what it looks like here. My dashboard, I'm signed in here. So we can see all my users here. The password's good. And I've created a little user down here. You'll notice here, I have a very large amount of IP addresses here that took a bit to add. I will walk through what you need to add here, but the primary reason for this is because it's secure by default. And so you have to whitelist every single IP that you want to connect to your database for security purposes. So I had to add all of my function app IPs, the possible ones I could come from in order to talk to it. So that's what that is. So, all right. So if we connect to the cluster here, just to kind of poke around a little bit, see what we got. This is the experience, the tool here. So going to the Stock Exchange database. This is a bit of refactoring I need to do, but I came up with a better name of Exchange as the aggregate. I called it Market Week. It doesn't have as much of a ring to it, Market Weeks. So I changed my mind on that. So classic developer thing. So, but these are the exchanges here. So, but we can see all our data here. So the exchange that we just created week of March 28th. So empty markets array here, but we can see the week is present here and it's inserted into the database. So, all right. So you maybe ask yourself, if you've never worked with Azure before, how do I get this function into the cloud? And there's many different ways of doing it. You could set up a pipeline, Azure pipeline, if you really want to set it up to repo. But if you're just playing around with this and just trying to have fun and just kind of explore, there's this handy Azure tool or extension that you can add to VS Code. You'll notice I have this nice little button here, deployed to function app. So if I click it here, I can create a new function app in Azure. So I could say something like Stock Exchange. Actually, you know what? I'm going to do this a little bit different. I'm going to go to the portal here really quick, and I will show you the portal experience here, just to kind of walk you through that. So go to portal.azure.com, sign into your account here, and just create an account. So we'll go ahead and create a function app here. So we're going to say a new one. So say it's my personal, we will say Stock Exchange. This is just creating a big resource group. Yep, you can see I've already run through this once before. We're just going to say .NET. Let me zoom out here a little bit. It's a little zoomed in. All right, .NET. And 3.1 is the version we're on. I will actually mention Fsharp, at least I don't recall specifically which feature it is or if it's just Fsharp in general, but 3.1 is important to the code that I'm running on, and that is what my FS project is set to. So if you download my example, play with it, .NET 3.1. So we'll go to review and create here. So this is the whole experience here. So we got our function app get started. We're going to create. So we got a consumption plan going. So you're good to go. So it is deploying, super easy. And we'll give it a second. Should give you like a little game or something, kind of like the T-Rex game in Chrome. There we go. That would be that's my future request. Maybe Pac-Man, something like that. Feel free. This is a great time. So during deployments like this, if there are any questions or anything like that, feel free to toss them in the chat, and I will do my best.
So Andrew, I have a question while we're waiting.
Sure.
Yeah, so I think on one of the slides you said, or it was stated, does Beeline use F#? And I don't think you answered that question.
Oh, that's a great question. Not currently. Well,
okay.
I think we used it for like some like transformations and stuff like that. So maybe tooling, and that's another place that F# shines. And that's honestly usually what I see demoed a lot at code conferences is that, and it's very good at that, especially with the fact that type providers feature where you pull types in from a type provider. But I wanted to show it as an API too here, just so that way, since it's always kind of relegated, I think, to like that tool context or something like that. So it's also, I think, very good for business purposes. But yeah, so not yet. I guess would be my answer.
Okay.
Maybe in the future.
And so I know, Beeline as a company consumes and produces a lot of APIs. Mm-hmm. So, one of the things I would ask you is, what are some of the things that you can do in F# that are very difficult to do in a C# based API production consumption paradigm, that. And I don't want to just get into terseness of code and things of that nature, because it's obvious that, F# is a terse language, but more in terms of things that are easier to do in an F# context that are just more difficult to do, like in a traditional C# context.
Dang, that's a great question. You're speaking my language, man. The best thing for me. So this is from Scott Washington. I think it's a quote from somebody else. So the best thing, I think, one of the best features of F# is its ability to, as Scott Washington walks through here, he essentially creates statically typed state machines in code. So I think for business purposes, like he has here, and I've actually, so this is kind of borrowed from a talk I gave on TypeScript. So this isn't the only language you could necessarily implement this in. But I think compared to C#, where it is not a function first language and it doesn't have things like sum types, code like this is very awkward to write. So like your question's addressing, I think things like this, especially stuff like this right here, where business requirements, I feel like there are a lot of things that corporations chase right now, specifically with unit tests, static analysis and stuff like that. And I think here with static types, I can think of nothing better because tests get slow, stuff like that. But having the compiler itself enforcing business rules and encoding them into it, into your code base. Everybody has to get the code compiled to deploy to prod. So I think the practice of this itself makes your code so much safer. So I'm definitely sold on that. And specifically with APIs, as he kind of models, I think, in his book. I have his book here that we've been going through at Beeline. I've been leading a book, a club there where we've been going through it. But I'm convinced that this is great for APIs, because that's all APIs are: transformations with concrete states, state machines. So you can gain if you can let the compiler do the heavy lifting of ensuring that your transformations line up. Because I tend to find that's the hardest part about web development is integrations and accounting for all of the states that can happen with them. I think I think his example here does a great job at solving that problem. So what I've actually
I was just going to ask if you could paste the link in the chat for this.
Gladly.
But the one, and I haven't used F# or worked with it in any way, but what wasn't immediately clear to me when you were showing the example, because my mind doesn't work that way, right? I've been working in C# since early 2000s. So and so my mind works in that world. And so it wasn't immediately apparent to me, looking at that code pattern that you showed, how the compiler was going to help me. So I don't know if that's something that you can like take a moment and sort of break that down. Like, how would the compiler help me in that scenario, that simple scenario that we saw, where it may not help us in a C# context?
That's a great question, man. You got all the good questions. Yep, that's perfect. Yep. So in my example, I kept it kind of simpler, admittedly, for this demo here. But and to be honest, I'm borrowing a bit from Fsharp itself with their result type. But yeah, even these pattern matches here. So as a general practice, I'm kind of just barely, I think, leveraging it here because it's a very simple project. But here, essentially, I'm getting a type back from this update market repository. So a common pattern that I find really good in functional programming with Fsharp in general is I can model the return types here. And like you were saying, in a C# world, typically we just return like an object, and it could be null or not null, and we throw exceptions. So, and that's the common way of handling it. And in functional programming, you can still throw exceptions in Fsharp, to my knowledge, but it's generally discouraged because, and the problem with it is, and I think Java and C#'s approach to it in general, this is my take on it, but they kind of both dance around the problem. So C# just expects you to try catch. So you've got to kind of know what the other guy wrote and what to catch under, from his function. In Java, they get very verbose with it and put the throw syntax into the function signature itself. I feel like Fsharp itself and other functional languages do a great job at solving that problem for good. Because they simply just encapsulate types. So I can simply say, like right here, I could say, well, the update operation itself, it could be successful, and then I get an exchange back as a result of this update. I could also get not found, or I could get an error. In my consuming code here, jump back to the right place, it's forced to match against it. So I have to handle every single case that's possible here. So I'm basically forcing the consumer. So if I like your question is very well worded, totally set up perfectly for this case here. So if I was to write the database handler and have some other developer pick up the other piece, I would feel confident with Fsharp knowing that he would have to match against this expression here. I could toss this over to him and he would know, okay, well, I got to match against this. And when it's successful, I get this type here. But I also have to handle these other two cases explicitly and account for them. So I think it helps clarity of the code. So you don't have errors lurking under the covers, specifically with I/O. I think that's like a very hard part of programming, I/O. And it also helps, I think, with refactorability. So jumping back into the repository here. So whenever, say, we have another state I need to add, so I could simply add it in here, and it compiles here. But if I go, my tooling here is a little slow here, but it'll actually catch up if I recompile it, and it'll yell at me because I'm not exhaustively matching this expression here. So that's also helpful too.
So that question prompted another question, which is usually how questions work. Mm-hmm. The thing that I see that's missing there is I like the idea that you can define some context around your types, right? Which is what you're doing. You have that higher level, saying these are the things that I expect. The problem is that when you're working with external APIs, what you expect may not be what you get. So you can have this definition that you arrive at and say, well, this is what I expect, and then Joe Blow API person decides they're going to change that out from underneath you, and now things don't line up anymore. Mm-hmm. So what is that? How does Fsharp handle those types of situations when what you've defined as your expectations around your type no longer hold true?
Mm-hmm. Yep, that's a great question. Yep, and the modeling piece of it. So off the cuff, my response to that, if I was to write this in F#. So I think that's a great candidate for for those for the previous question. So this is where the wording comes in. So F#'s giving me a bit of nudge that I've not exhaustively type checked here. To your question there, I think that's actually the way I would handle that is I would model. So if I was integrating with another API that I don't trust, I would model that with a result of T. So let me see if I can find a good use case of that, and I'll back this out here really quick. This is a little bit convoluted. This is just some code I was playing with, but there's this result type within F# here. See if I can find a better use case. Here's one, result of T. So that's an excellent question, and I think the best answer to that in a functional sense is to wrap it with a type. So if I'm unsure that this other API could change, it's always best to plan for failure. So it could work, or I could get a string, error message back, and then model it that way. You're correct in that, and that's a very good point, in that it's not a silver bullet, in the sense that without an integration test or something actually running that endpoint, if Joe Blow over there decides to not throw a curveball our way, there's no way the compiler will know about it because it's not a type. But our consuming system here can kind of defensively act against it, in the sense that we could say, okay, well, Joe decides to throw us a curveball that day. I need to, obviously this is a different context, but I need to wrap it with a type. So I model it as it could fail. Joe could have a bad day, so that would be my thinking about it.
Okay.
I believe Haskell does that way too. So they take it to the nines with the IO monad and all that. But even with them, I think that it's possible to have, so they have a couple of functions, to my knowledge, that pull straight from from a file, I believe, and it could still bomb. So, or parse an integer. That's what it is. So it could, if you don't hand it an integer, they provide it for convenience if you're doing like a quick one-liner, but it's kind of frowned on. So because it's unsafe. So it's so they would probably say it's not modeled correctly, because you always have to model the sad path. So yep.
Okay.
So I this is a great question. Great question. Is it, like all things with all tools, like you can, the way I see it is, if you, just like even in an object oriented sense, I think this is kind of some overlap. Like if you don't use the tool correctly, or you don't account for all the cases, there's still only so much it can help you before, if you don't model if the problem isn't modeled correctly from the start, then it can, you can still have bad effects happen from it. So, but yeah, it was a great question, man. You're totally, speaking my language. So that's awesome. But yeah. And I'd highly, I think I posted this in the chat. This is a very much more complex solution a much more real world and complex solution that Scott Wolaschin represents, where he takes this a little bit further. And I think if you're curious about this, and my talk has spurred some curiosity, this is a great place to have it explained a little bit deeper, a little bit more concrete, outside of a fun little Animal Crossing example, where we could take a business problem and represent it. He also has in his book a good example of a shopping cart, and modeling that as a state machine itself. So it's types transitioning. So obviously, in an object-oriented sense, you can't have, I can't, for example, check out with an empty shopping cart, right? So I can't jump the state machine from empty cart to checkout and pay for it. So he models it as a state diagram, and then uses the types themselves. So transitions happen with functions themselves, and it only allows you to move to the proper state within the type system itself. So all of the type signatures, for example, the checkout function will only take a shopping cart that's not empty. So just kind of to touch on it slightly. So I don't want to get too off the rails, but that's kind of the general idea. So taking the concept Michael Mann and I were just talking about, and moving it a little bit further. But I see tremendous value in that. because to me, that's what a lot of unit tests try to achieve. So high test coverage. But if you can bulletproof it with types and get the type system itself to do it for you, it's a great thing. So, and actually, there was a really good talk. I'll link it after. I'll have to look up the author again. But at RecentConf, I've been doing a little bit just to kind of go off the rails a little bit here. So there's a new language out of Facebook. This is front end, but they've actually kind of had some issues with TypeScript in terms of how slow it can be because they're Facebook and they have tons of code. So, so they've naturally written their own new language. This has a lot of the same concepts I've just touched on with Fsharp, and they adopt the same principles. But if you look at their type section here, they also actually are bringing these concepts to the front end. So you'll see all their arguments about how they modeled their problems on the front end, because the front end has very similar problems in terms of yeah. So they'll talk about it looks very familiar to the Fsharp code I just showed. So yep, result of so as Michael Mann was just very well pointing out, always modeling the sad path diligently, accounting for errors. And they model it here, but they're taking that same concept and applying it to the front end. So I'll see if I can get that linked to the host of this or put on the YouTube comments, the talk that I'm referring to. But there was a great talk where the author at RecentConf was taking these ideas here and comparing them to unit testing and putting them basically in the same camp as far as they're just tools to solve the same problem. I need to make sure my code, when I ship it, it works. So unit tests can be my friend, integration tests can be my friend, and modeling types correctly as much as possible can help achieve that. So my compiler itself is checking valid states along the way. And I think as a developer, as I've gotten used to reading type signatures a bit more and relying on it, I think interacting with results rather than side effects helps a lot too, because you can gain that assurance. Hopefully that's making some sense, but I'll link that talk afterwards. But yeah, excellent question. So, Rescript here, if anybody's curious, a lot of fun to code in on the front end. So if you're in React, you'll love Rescript. So, all right.
I'll ask you another question if you don't mind.
Sure. Yeah, keep coming.
All right. So your day job, you write in C#, is that correct?
It's a mixture. Done a bit of front end, bit of back end. So I've done a little bit of Vue.js recently. So I used to be a big React guy at the last two jobs. And TypeScript. I've done a bit of Vue.js at Beeline. Since being back at Beeline, a bit of Node. So it's been a combination of those two, and a lot of Kubernetes. It doesn't count a language. Kubernetes manifests have been my world lately. So
I was going to ask if some of these concepts have carried over into the non-functional languages that you've worked in, which are typically OO type languages, or maybe not so much. Like TypeScript is just another layer on top of JavaScript with types. Mm-hmm. But are there any specific approaches that you've taken from what you've learned in an F# type language to apply it in these other languages that you do in your day job?
That's a great question. Yes, absolutely. So obviously to varying degrees. So specifically with TypeScript, and I'm glad you brought it up. So when I was my last job, it was insurance context. So I actually modeled. So this is just a little code snippet I wrote, but you can actually model this exact same problem as we're doing with F# in TypeScript. It's a little bit more verbose. But you can absolutely achieve the same thing. You get type safety. So here we have our state machine rendered. So, if the user's filling out a sign-up form, I'll scroll down to the bottom here so people can see it in action here. Past the code snippets. There we go. Yep. So, yeah, so this is using, so this is the Redux Dev Tools over here on the right. And then we have a little sign up form. So this is a great, I think, in this case, it's a good business use case, common thing. I need a user to sign up, and I need to make sure that they have a first name, a last name, and a valid email address that's not empty, So, and I need to provide some errors to the user along the way. So you can see here in the bottom, so Redux itself is in fact just a big state machine. So these, I think, TypeScript and Redux fit very well together. And it makes your code a lot safer. So you'll see in the code snippets here, I've had to write my own function since TypeScript doesn't have pattern matching. So I had to create my own match function here, but it reads very similarly, just more curly braces, but the same general idea. And it can be done and achieved, and we just map over to JSX. But this allows the view itself to match against the possible cases from the Redux store. So you can gain that type safety that you wouldn't have otherwise. Having programmed in React and Redux without TypeScript and with TypeScript, I definitely prefer with TypeScript, just because there's so many times where I would grab, I forget what the property was named, stuff like that, or what state. Obviously a lot of reducers, I think, tend to have Boolean values and stuff like that, like you were just saying. So like a lot of primitive obsession, modeling, objects and then just flipping flags, like it's common in OO. So in this case, we use the types to drive the view here. So my view here actually, in my opinion, reads a lot clearer in the sense that when I don't have a valid email, I show errors. And I get the errors within my closure here. So I think they dovetail very well together. And I think that can be done. Obviously, I think a node without TypeScript, you can use JavaScript's map functions and stuff to achieve functional structures. But you won't get the type safety without TypeScript. But if you convince people to use TypeScript, I had a great time with it. In my last job, we implemented TypeScript all the way through our front end. So I actually got the chance to get in on the project early. So I was the lead developer over there, and I introduced to the team TypeScript, and they learned to, I think, like it by the end of it. So it was a great experience, and our code base was a lot easier to refactor because of it. So yeah, so hopefully. Hopefully I've answered the question decently, but that's been my experience.
Yeah, if you could put a link to that blog post in
sure.
the chat, that would be good for anyone who's interested.
All right. Perfect. I'll pause here for any more questions. And I am looking at the time here, so I don't want to keep people too long. I'm not sure how long the talk was slated for, but I can, while I wait for questions, go through here for this last little part here. So now that we've deployed this resource, so in Azure here, we can toss this up here into our Azure cloud here. All right, and connecting. Let's see if we can give it a refresh here and see if that changes something. There we are. Okay, I just had to give it a refresh. All right, we're going to say yes. Please override it. Good stuff. All right, and it's that easy. So if you've never, for those who haven't dabbled in Azure at all, I know for me, whenever I went to a lot of talks with AWS or Azure for a long time, I'd see somebody show me all these cool things in the cloud, and it's like, it could be a little intimidating. With Azure, is that they've made it very accessible for function apps. So even if that's like your first exposure to it, feel free to give it a shot. It's that easy to do it. It's free for the first 1 million executions, I think, or something like that. So feel free to give it a shot and play with it. So I've had a lot of fun with it. it's kind of surreal seeing it be that easy to deploy something and then have a function app that can scale. So pretty wild. So feel free to give it a shot. So yep. All right. So there we go. All right.
Hey, Drew, if you can put the links in the private chat, I'll post them on the YouTube. I don't think you can do that.
Sure, absolutely. All right. I think that's all of them. I believe that last one is coming back to me. It's Ryan Anderson. Oh, it wasn't Ryan Anderson. So I'll look up whoever, whoever it was at RecentConf that gave that talk for Facebook. But he gave an excellent talk on type-driven development and how that can fit in. So, all right. So let's go back to our function app here. All right. So we can see here that we got our function all deployed up and running here. I'm going to grab the function URL. So this should look familiar. So this looks a lot like the route that I set up. So that's good to go. Now, I will say the caveat is I've not added the configuration for my database. So we are probably not going to get a good result here. And I am completely new at streaming, so I do not want to paste my connection string. So when you deploy this, I will offer a fair warning that go to the function app over here and add your connection string in, and it's under properties or configuration, I believe, right over here. So you just toss your connection string in, and you're good to go. But yep, so yep. But you know what? I'll just make a new one. So, well, okay, never mind. But that's the general gist of it. I'll give it a shot. All right. All right. I don't know if I did that right. I may have copied the whole line. I did. I'll just create a new one after. So, yeah. So that should work. So we're good there. And I need to save. Good stuff. All right. So we are good to go there. And if all has gone right, I need to wait for it to save, apparently. There we go. Good. All right. You're up and running. And give it a second. I think it's restarting because it's redeploying that configuration I just added. You're good to go here. We're going to grab the exchanges. So we're going to go over to Postman here, add a new tab here. All right. And we need to add the key. We add the key. So go over to function keys. And we'll grab this value here. Good stuff. All right. And it's that easy. And, well, shouldn't speak too soon. But good to go there. It's sending.
Andrew, while we're waiting, have you used the, so you can run function apps within VS Code? All you have to do is install the storage emulator and you can run them directly within VS Code.
Interesting.
It's pretty nice. You just have to install, like I said, you have to install the Azure storage emulator, and then you can just F5 debug locally.
Very cool. Very cool tip. I will have to give that a shot. So, Very cool. Yeah, it's I don't know how AWS has come along, but that was, I don't know if they have a thing. I know they have the serverless GitHub site, open source thing, I think, to run locally, but I don't know, do they have an official thing? I don't remember them having it. I found it really nice with Azure being able to run it locally.
Yeah, it's the one thing I like about Azure Functions is the the triggers they have. Honestly, one of the triggers I've used a lot lately, believe it or not, is just the timer trigger, which if you need something to run on a schedule, I mean, it's perfect for that sort of thing.
Mm-hmm.
But they have a whole collection of triggers that you can have your function run on HTTP and messages coming in a service bus queue and all kinds of stuff.
Mm-hmm. Gotcha. Yeah. It's pretty wild. The bit of stuff I've done with with them has been great. And logic apps, stuff like that. It's so easy to just put them together. So yeah, for anybody that's not dabbled in Azure or done anything cloud, I should say, it's a lot of fun. So very, very good points. So I've run into this right here. So if you get this when you try to run my code here, this is coming from Mongo because I'm guessing, I was hoping that the list of IP addresses was static. It looks like it's not. So I'm going to do the super secure open to everything briefly for the demo here. This should deploy in MongoDB. So this is a good, I guess, troubleshooting tutorial as well. So all of these did not save me apparently from the security, which I guess is a good thing. But that's what's going on there. So that's why I'm getting a 500. But we can see our, for what it's worth, we can see our error handling working very well. So we get our 500 and our information here. So we're good to go. All right. All right, it's active. Good stuff. All right. So now let's give it another shot. Hey, look at that. All right. Yep. So that's all that's going on there. So there is a way to grab the IPs, outbound IPs. I believe it's under Azure Storage Resource Explorer. And you have to, if you Google it, outbound IPs for function apps, you'll see it in a Microsoft tutorial. And they'll walk you through where it is. It's a little bit to get to. You got to go through their JSON records of your function app, but you'll see it in there. So and then go through the approach of adding them in, or you can just sort of do what I did and play with it. If it's not an app if it's an app you're just exploring and don't really care about, and then do this and then just delete it. But all right, cool. Well, and then we should have it. Give it a test. Probably take a second, but anyways, that's the general gist. So we don't have to wait for it to propagate, but that should lock it back down. Yeah, deploying your changes. So I will go ahead and pause one more time for any questions. These are the resources here, that I've linked and gone through here in case anybody wants to look at up these on their own. And I'll also post a link to the slides in the comments, so people can view those after. But all right. So thank you all for coming. And any questions?
Any questions from the chat? So while we're waiting, so you transitioned back over to Beeline, sounds like,
Yep.
And so your focus there is mostly on front end type work.
It's been a mixture. So the last 2 jobs I've had have been a mixture, but it's been more 75 25, I think. Three quarters of it was front end, and then 25 was back end. Just kind of pitching as needed. I found there's a huge gap of people that are good at front end tech, like React, Redux, stuff like that. So that was kind of the hat I had to wear to help get it off the ground. But with the TypeScript, you could easily. I just did the same thing that we just went through with Fsharp, and you can transition that same pattern over between the two. But yep. So yeah, at Beeline it's been about I'd say probably, well, actually, so I've actually been doing a lot of infrastructure. Honestly, that's been the majority. If I had to, so it's like another category I've been kind of introduced to with Kubernetes. So they have a Kubernetes cluster they've set up and had to learn Kubernetes manifest. So it's been a fun exercise. So I know there's a lot of Kubernetes jokes out there about learn Kubernetes in 500 steps or 500 easy steps. I think there's a book out there like that. So that's been my. I think it's true.
Nightmares of YAML.
Yes, exactly. Yeah, and yeah, right. It's beautiful when it works, but oh man, the pains you have to go through to get it, the transforms, and yeah, it's been a way
to declare your suffering. It's a way to declare your pain and suffering. Is
a wonderful way to put it. Yep, that has been my experience.
We do have a question in the chat. It says, "Do you have any upcoming work projects you think you'll do in Fsharp?"
That's a great question. It could. I think. Not that I know of. I guess this is the right answer. But so I think. Yeah. But that could totally change. And I think you could apply it. Excuse me. I think it can be applied to many different areas. So like with web APIs, Azure Functions here. So I think it's a great thing. I think the hardest part for me, so I found actually, so if anybody's looking to implement something like this, my 2 cents would be TypeScript. Because I think it's got that familiar, everybody kind of knows JavaScript somewhat. So I found that's a good a gateway, a way of getting people used to some functional ideas. I actually had a lot of success with that at my last job. We used a framework called FPTS. And it's written by this Italian rock climber guy who's a math wizard. So if you be warned, if you read his blog, most of it goes way over my head. And these are his inspirations. So take that with the caution it deserves. But the overall use of this library is great in terms of it has option, it has either, and they're all written in TypeScript. So you gain all the type safety of these what are type classes in Haskell adapted to TypeScript. And I've had great success with people being introduced to these patterns. So it's kind of dressing it up in a different way. It helped me get past some of that. So my if that was where I guess I'm making some assumptions as to where the question was aimed there, but I found that Fsharp itself, I personally have enjoyed working with it in side projects and stuff like this. But I think sometimes when you drop it, on people, they're like, I don't want to learn a new language, stuff like that. This looks scary. But if you say TypeScript and then you introduce some functional concepts with it, it's kind of like, I guess when parents, put, they dress up vegetables as something else. It's the same idea, I guess, in my experience is okay, that looks a lot easier. It's the same concept, just put into a more JavaScripty sense. So, for what it's worth, that's been my experience with it. But yeah, I think Fsharp kind of has the one thing about it is I think you have to get that group consensus and team consensus going as far as people feeling comfortable with working with it, and everybody on the team on board and management on board, because it's not as popular as C#. So from a pragmatic standpoint, the replacing or adding new Fsharp developers may be a harder sell than TypeScript. But
what do you like as a good TypeScript editor?
So I'm a bit vanilla, but I love VS Code. So I use VS Code for TypeScript and use it for. I've fallen in love with it. I briefly used Emacs I think it was VS Space or Space Code, Space Max. I say Space Code because I use the extension for the emulate Space Max in VS Code. But since I got that extension, so I have that going, so I can navigate around. So I like the Space Max experience in VS Code. That's my configuration and my setup that I like. But that I found VS Code has great support out of the box for TypeScript. So I've liked that in the sense that whenever, like with the team that I led at my last job for the front end, it was easy to get everybody to just install VS Code, and it all just works without having to have them all install a bunch of extensions. So
yeah, that was my experience. I had to install a bunch of extensions, and I was having some problems with it. So
yeah, that's exactly. We actually had some developers that were, I like this other editor, and then they fiddled with it for like a day, and then they came to me, and it was exactly. It's just very, very much anguish, and then I was just like, it just installed VS Code, and it just worked. So they it may not have been their favorite editor, but they it to its credit, it works right out of the box. So I've enjoyed it. So yep.
So are we caught up on all the questions? Anybody else have any more? I know there was one early on, Drew. I don't know if you saw that, but someone asked if you guys were actually using Fsharp at Beeline.
Oh, gotcha. Yep. I think Michael Mann may have mentioned that a bit ago. Yep. Not currently. So not in any production sense, like I just demoed. So maybe for transformations and stuff, like transforming like JSON files and stuff like that.
Right.
But yeah, for an API, I don't think any of our APIs are yet written in Fsharp. But who knows?
Yeah, I don't know anybody who uses Fsharp at all. I mean, out of all the companies I've talked to and worked with. So
yeah, it's definitely still predominantly, I think, C# in the .NET world. So and with the way things are going, I kind of find it funny in the sense like C# introducing record types. So they're kind of borrowing, I think, a lot of Sharp 9 non-rollable reference types, record types. So a lot of the stuff, pattern matching enhancements. So who knows? Maybe C# will and Fsharp will merge forces at some point. The way it seems to be going, but
they seem to be consuming a lot of things.
Exactly. Yeah, it's starting to. It's so who knows? I guess that's actually probably to Michael Mann's last question about coding and even these features right here. If you're in C# and stuff, these concepts are probably a welcome thing to you because they're starting to mainstream it into the language itself. So
yeah.
Yep.
Cool. Well, thanks for sharing the time and spending time speaking to us.
Oh, no problem at all. Thank you guys for having me. It's been fun. So yep. Awesome.
Cool. And thanks to Mike for tracking you down and bringing you in. So the session will be available for view later. It's been recorded. So we'll post that link. It's actually, we won't post the link. It's the YouTube link. So you can go back and watch it afterwards anytime you want. So awesome. Well, thank you. And we will hopefully see you next month.
All right. Awesome. Sounds good. Thank you guys.
All right. Thanks.
Take care.
Yep, take care.